Yeah. Good evening, all those who have come right now, who have joined right now, who are listening. Please write your name and enrollment number in the chat box for attendance. And we are starting with the session, that is BCS 11. So, are you able to see my screen?
Yes, ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
first and foremost, we needed to understand what is a computer, right? Can anybody tell me any definition you know? What is a computer?
Computer is an electronic machine which performs mathematical activity like addition, subtraction, and some critical actions also.
Yes.
Uh, Also nowadays it helps us in information technology. Like if you want to shop online, we can book our ticket online.
Right.
So many operations can done by computer.
Fine, fine. It's okay. You have said right that it's an electronic machine. It is completely digital, right? That's why it is electronic machine, which it can calculate also, it can store also, it can process also. So there are many things which the computer can do, right? So how does the computer came into existence? So first we need to understand that there is a history of computers, right? So, from the analog, first, what we had was in electronic era, analog computers. Do you understand what is analog?
Yes, ma'am.
Yes, ma'am.
Anybody understand what is analog? Analog means what?
Yeah, a physical and tangible form.
Yes, and analog also means that it is in continuous form, right? Like thermometer, earlier thermometers we used to put in our mouth, right? So there was a mercury inside, an element. When our temperature was more, then the mercury used to rise, right? So physically it used to count. The scale was there. So wherever the mercury keeps on getting above, so we used to count that this person has 102-degree temperature or 100-degree temperature, right? So that was analog machines. They were not digital machines. So from analog to digital, how the machines have come. So the calculating device, the first early calculating device was abacus. Has anybody heard about abacus? It's a Chinese device.
Yes, ma'am.
Ma'am,
Yes, ma'am.
Yes,
for
ma'am.
addition and subtraction we can use.
Yeah, this is
Yes.
a Chinese device. It has heaven and hell. The above beads were heaven and the below beads were called as hell. So in this way they used to calculate addition and subtraction they used to do. So this was the earliest calculating device, right? So this was the first one through beads we used to calculate, abacus, right? Then came Napier's bone. Then another machine was Napier bone. It was developed by John Napier and it could do multiplications and divisions. It has 11 sticks or bones, you can say, which were placed side by side, and there were numbers and all the things were written on that at that time, and through that they used to do multiplication and division. This was also one kind of machine which could do multiplication and division by John Napier. It was known as Napier's bone, right? This was another machine known as Schickard's machine. And Wilhelm Schickard was the German scientist who invented this machine in 1623. And he used wheels to add, multiply, and divide. There were different kinds of wheels which were used to add. This was another machine for calculations which they developed. This was developed by Wilhelm Schickard, and that's why it is called Schickard's machine. This is known as slide rule, and you have slide rule was developed by William Oughtred, and it consists of two movable rulers placed side by side, and through these rulers you need to do multiplication and division. This was another calculating device which was used at that time, right? Then came Pascaline machine. This is Pascaline machine, and it was developed by Blaise Pascal. He was a French mathematician, and he developed this machine to add and subtract. And it comes with gears and rotating gears and wheels through which in the decimal number system calculations were also done. So this was another machine by Blaise Pascal. So that was known as Pascaline. Right. Then came Jacquard's loom. If you see this, this is a actually used for making cloth. Loom. It is a loom, right? So it was generally made for making a cloth, and this was developed by Joseph Marie Jacquard, a French inventor. And the machine uses punch cards. Punch cards were earlier used to keep data, or you can say program inside it. Earlier there was no hard disk or pen drive or such kinds of things for keeping data, so you had punch cards to keep data stored. So they used to keep program designs on which they made on fabrics and carpets, and through this loom they used to weave the carpet or the fabrics. Or so this was another machine where punch cards were used. So this was developed by Joseph Marie Jacquard. So it is Jacquard loom. Now this is the machine which actually started, we can say, the computer era needed started at this time, because this was a machine developed by Charles Babbage, and Charles Babbage was also known as the father of computer. Do you know that? All of you know that? Who is Charles Babbage?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Charles Babbage is
Charles
known
Babbage.
as the father of
Yes, ma'am.
computer. Why?
Yes.
Why? Because he developed two mechanical devices, electromechanical devices, you can say, or mechanical devices that were difference engine and analytical engine. One more he developed for calculations. So Charles Babbage, an English mathematician, built a working model of an early computer-like mechanical device that called the difference engine, that can solve mechanical problems using the capacity of one of the machines, or it was not an electronic machine, it was totally mechanical machine through which it would calculate. Another, hello, and another one was analytical engine. So these machines, later on we thought we should make a system where we could calculate different things, and that started development of computers. So that's why Charles Babbage is called the father of computer. Right. This is another machine called as Hollerith tabulating machine, and he was an American inventor and designed a coding scheme and a mechanical tabulating machine which used punch cards that can be electronically read to process high volumes of data. So basically what happened is Herman Hollerith, he was an American inventor, and he designed a coding system. So those codes or data could be kept on punch cards, and punch cards were the early storage devices. So this was another machine. So right now what they were developing is that we could keep data saved inside some punch cards, and we could use it later on also. So that was Hollerith tabulating machine, designed by Herman Hollerith. Now if you see this is developed by Howard Aiken. This is the first electromechanical digital computing machine, Mark 1. This was the first computing machine developed by Howard Aiken, and this is known as Mark 1. In first generation computer, when we talk about generation of computer, in first generation this computer came, the first computer, electromechanical digital computer. So this was Mark 1, right? So it required a whole room for a computer to be kept. Huge room was required, and I think vacuum tubes were used at that time. Like right now ICs are used, your integrated circuits are used in your computer. At that time vacuum tubes were used for processing, right? Now we talk about, these were different machines or history. Now we talk about generation of computer technology. So how the generation of computer started. So the first generation computer we generally talk about is from 1940 to 1956, right? So at that time the technology used was vacuum tubes. Vacuum tubes were just like bulbs, right? Like old time bulbs you used, which had filament, the same type of thing was used in vacuum tubes. So the first computers used vacuum tubes for circuitry and magnetic drums for memory, and were often enormous, taking up entire rooms because vacuum tubes, many vacuum tubes have to be put in the computer. So you require a whole huge room, entire room for the computer to be kept. It requires a lot of space. So they were very expensive to operate, and in addition to using a great deal of electricity, generated a lot of heat. So what happened was you required lot of electricity, lot of air conditioning you required. Heat was generated a lot because so many of vacuum tube bulbs were used. So a lot of heat was generated, which was often the cause of malfunctions. Malfunctions means whenever suppose one of the vacuum tubes fuses or something happened, so the whole computer doesn't use to work. So there were many problems with the first generation computer, and at that time magnetic drums were used for memory. So if you want to keep a memory, so there were magnetic drums on which memory was stored. So that was first generation computers, and it uses vacuum tubes from 1940 to 1956. So you had space problem, you have electricity problem, you have AC's problem, you have because of heat. So these are the problems. So this is a vacuum tube, right? This was a vacuum tube which were used at that time, kind of circuitry filament. Then came second generation computers. Second generation computers were from 1956 to 1963. Right. So 1956 to 1963, now from vacuum tubes, the technology changed to transistors. Now transistors were used. So transistor replaced vacuum tubes and ushered in the second generation of computers. The transistor was invented in 1947 but did not see widespread use in computers until the late 1950s. So it was invented in 1947, but its usage was later on in 1950s. It was used. So transistor was far superior to the vacuum tube because it was smaller in size, allowing computers to become smaller, faster, cheaper, more energy efficient, and more reliable than the first generation predecessors. So what happened was, because the using of transistors, what helped in the second generation was that they become smaller, right? Still a room was required, but not a bigger room which was required in the first generation. Then they become a little faster, cheaper also, little from the first generation, and more energy efficient. A little less heat was generated, but there was heat, so ACs were required. So this was what the advantages from the first generation. Though the transistor still generated a great deal of heat that subjected the computer to damage, it was very a vast improvement over the vacuum tubes. But it was an improvement over vacuum tubes, so that was good. The second generation computers still relied on punch cards for input and printouts for the output. So basically, second generation, like first generation, punch cards and magnetic drums were used. Same way in second generation, also punch cards were used for input and output printouts of the output. So that was second generation computer. Then this is a transistor. This is how a transistor is. And now the transistors are used on your ICs, are miniature ones, and your IC have become very small size. So now it can fit in your mobiles also, no? So smaller it has become. Right. So then came third generation computers. So in third generation computers, it was in 1964 to 1971. Third generation computers were from 1964 to 1971. And at that time, integrated circuits or ICs technology were from transistors, ICs started to be used. This was the generation where ICs have started. So the development of integrated circuit was a hallmark of the third generation of computers. Transistors were miniatured. Now transistors were made more smaller and placed on silicon chips. Right, silicon chip is your IC chip, and on that chip, miniature transistors are put, called semiconductor. The chip is called the semiconductor, which drastically increase the speed and efficiency of computers because many integrated circuits in one integrated circuit, many transistors, miniature transistors were put. So your speed was good, efficiency of the computer became good. Instead of punch cards and printouts, users interacted with third generation computer through keyboard and monitors. And now keyboard and monitors have also come, so you could see what is happening, and you could also have keyboards to type and all that, and interface with an operating system. And an operating system also came. Earlier, no operating system was there. Whatever you have to put a program, you have to put it in the punch card and feed it in the computer, and it will calculate and give you an output on the punch card only, right, or printout. So now your third generation computer had keyboard also, monitor also, and you had operating system also. So which allowed the device to run many different applications at one time with a central program that monitored the memory. So your operating system was managing everything, and you had different applications or run on that operating system, and you could run that device. So computers for the first time became accessible to a mass audience because they were smaller and cheaper than their predecessors. So now, earlier computers were not used by normal persons or only bigger scientific applications or business people used to use it. Now it has become a mass audience. So now in from third generation in foreign countries, they have started using, normal people had also started using computers. So that was third generation computer. So here your integrated circuits or ICs developed, and from here your digital computer which you are now using came into being basically. So this is an microchip, or this is your integrated circuit. This is how integrated circuit is, right? So these are the different transistors which are inside. The pin is coming out. So that is that. So then came fourth generation. Actually, fourth generation, we are in fifth generation right now. So we are not in the fourth generation. Fourth generation has also gone. So fourth generation computer is from 1971 to present. So you can say up to 2000 or 1999 or something. So microprocessor brought the fourth generation of computers as thousands of integrated circuits were built onto a single silicon chip. So basically, in third generation computer here, your ICs have how many transistors? That was the thing, integration, that is known as scale integration, and how many transistors are put on the chip, that depends. So in third generation, you had small scale integration. You have 100, 2000 or 10 to 100 ICs, that was small scale. Then 100 to 1000 was large scale integration. Then in fourth generation, now you had very large scale integration. So you have from 10,000 up to 10,000 transistors are put on one chip. So very large scale integration, VLSI is known as. So that is in fourth generation. That's why it is saying the fourth generation of computer, thousands of integrated circuits were built onto a single silicon chip. Right. So many ICs were put on single chip. So that is known as very large scale integration. So what in the first generation filled an entire room could now fit the palm of the hand. So now you have smart watches also. So on the palm of your hand also a small computer is working. So the Intel 4004 chip developed in 1971 located all the components of the computer from the central processing unit and memory to input-output controls on a single chip. So your microprocessor, which is the smallest chip or the silicon chip which you have number of integrated circuit inside, and your faster computer, and your size has also miniatured, small size. Your mobile is now a computer only, if you talk about. Right. So this is a microprocessor chip. Again, an example. So you have different companies which are developing the ICs, Intel, this is MBOS. So there are many companies which are developing the microprocessor chip. Right. Then you have fifth generation computer, which is going on right now, and we will be entering into sixth generation now. So fifth generation now, what happened? More and more now, 1,000 to lakhs integrated circuits are put in a single chip. So that is known as ultra large scale integration. That was very large scale integration in the fourth generation. Now is ultra large scale integration, right? So more and more faster your computer is becoming, and now in the fifth generation, your computers are based on more artificial intelligence, right? So what is artificial intelligence? Like when you open your Google, you can give the command to Google, also Google Assist, right? Right? You speak and
Yes,
Yes,
Google
ma'am.
ma'am.
gives you
Yes,
answer.
ma'am.
It is a kind of a artificial intelligence which is being developed right now. And if you buy something on Amazon or Flipkart or whatever, so there also voice assist is there, right? In Amazon it is Alexa, in iPhone's series there, right? So there are different kinds of things which are happening in through artificial intelligence. Also, when you are selecting certain things on your Amazon or Flipkart, so it gives you recommendations also next time that you may likely to buy this also, right? It gives you recommendations also next time if you visit certain pages and you see certain products on the Amazon. So what is that? That is artificial intelligence. That is seeing your buying criteria, your things which you are looking for, keep on looking. So it gives you recommendation on that basis. So it is following you actually. Google is also following you. If you keep the locations on in your mobile, Google knows where you are always, right?
Yes.
So this is all what is it? It is all artificial intelligence which is right now being going on. Though there are some applications such as voice recognition that are being used today, the use of parallel processing and superconductors is helping to make artificial intelligence a reality. So basically, superconductors are your chips, right? And parallel processing means many applications or many things are running side by side in your computer. So, and there are different algorithms which are being used for these things. So it is making you intelligent, artificial intelligent a reality. It is being developed, and later on it will be quantum computation and molecular and nanotechnology, which will radically change the face of computers in the years to come. So this is the new technology which will be coming after artificial intelligence. That will be quantum computing. The goal of fifth generation computing is to develop devices that respond to natural language input and are capable of learning and self-organization. So basically, have you heard about machine learning? Some of you must have learned
Yes,
seen
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
so that is what we are developing right now. What we are doing is we are making the machine learn itself, right? So that we don't have to do anything. It knows our input, our natural language input, and it does gives the output capable of giving its own inputs and giving you the output. So that is what is being developed. That is the goal of fifth generation. So we'll be going into sixth generation, and then quantum computing will be the next
Ma'am,
thing.
what is
So
quantum computing exactly?
actually,
Please
it is
explain.
based on nanotechnology. Quantum means 4 times the power of the computer will be increased. More processing power will be there, right? So there are like so in supercomputers. If you talk about supercomputers, what they do is they calculate in within a nanoseconds the distance between the moon and the earth, or the space, different things which they do in space. So they do that. So that kind of a thing will be there. Your speed will be too much, 4 times, right? So they will be developing that kind of a thing in fifth generation. After fifth generation, right now though you are into fifth generation, which is going on. So this is the technology which will be going on later on. So you have robots also right now working for you, right? There are different robots also.
Yes, ma'am.
So now the robots will be like a normal human also. Those will be having feelings also. So these kinds of things will be the future things which will be happening. So
Yes, ma'am.
that is what quantum.
I've heard about Sophia robot. She is
Yeah,
having
that is
artificial.
yeah, that is adopted by Saudi Arabia, right?
Yes,
So
yes, yes.
that is what I'm saying. It still has certain things to be developed inside it to make it a fully human-like feeling or something like that. So that has to be done later on. But still, yes, So they are going on to quantum computing, which will make the speed and the processing and everything very fast, and it will be a virtual reality kind of a thing later on. Right? So that is what fifth generation is. So there are different generations which we talked about. The first generation has vacuum tubes. The second generation has transistors. Third generation is an integrated circuit which has started. Right, fourth generation, the integrated circuits which have started in the in the third generation. You had the small scale integration, large scale integration, then came very large scale integration. In fourth generation, you have ultra large scale integration, which is still going on in fifth generation. So number of IC chips are increasing on a single microprocessor. So this is what the technology and what all things have come. And in third generation, one more thing is there, that operating system has started in this generation in 1964 to 1971. Right. So you had DOS, the first operating system, which is DOS, disk operating system. Right. So disk operating system, there were only commands. No, the graphics was not there, and no GUI was there. Graphical user interface. It was not graphical user interface. It was command user interface. So you need to give commands, and it used to process them. Right. So that then Microsoft launched one operating system 3.1, which had certain graphics. Then 95 came. Then Microsoft later on 2000. Then XP. Then you had right now you are running Windows 10, right? Windows 7 was there. Then Windows 10, and now Windows 11 has also come, right?
Yes, ma'am.
So
Yes, ma'am.
improvement is going on in the operating system also. Like same way in Linux, earlier it was Unix operating system. Another operating system is Unix. So it was command user interface. Later on they developed Linux, which is graphical user interface also. Right, so its version has also increased. So different companies are developing different versions of Linux. You have Apple's Macintosh, right? So Apple's Macintosh also has different versions which are kept on coming to market with different versions. And in mobiles, Apple is running iOS, right? So that's also improving day by day. The new versions of iOS also come in the market. So these are
Rahul,
the.
can you please turn off your mic?
Please keep your mic mute. When you are told to speak, you can speak. Right. So these are the different things which are there. Then in third generation, this was operating system was introduced. Then hard disk also came into being. That is your magnetic disk, right? So now punch cards and magnetic drums were not, or tape were not used. Now hard disk has come into being in from third generation. Now hard disk also had different kinds of improvements which were happening from smaller size to now it is terabyte, petabyte, whatever bytes have come, terabytes and all. So it also kept on improving. Then other devices also came into being like pen drive. Earlier there were floppy disk CDs, right?
Yes, ma'am.
Right. So CDs, DVDs have also lost their charm now. Nobody uses CDs and DVDs also. Now whatever you want to send the data, you either send by email, WhatsApp, this and that. Right. And there is cloud storage also. Now you don't keep also in pen drive and all that also. What do? Either you save it in your laptop or whatever system you have, or you save it in the cloud. Right? Like all those people who are having mobiles, so they are saving it in what form? Where is their data getting synced? If they have Android mobile, it is getting synced in their Google,
Google.
Gmail,
Google
right?
Drive.
Google
Yes,
Drive,
ma'am.
Drive and all. And if they are
OneDrive.
using iPhone, so iPhone also has its own
iCloud.
OneCloud.
cloud, right? Even if you are using company's mobile, like Samsung, if you are using Samsung is also giving you a
Cloud.
cloud-based storage, so you can keep your things there also. So different technologies is getting improved, different technologies are getting introduced, and you are started using them, and the old technologies you are not using now, right now, but they are still coming into being. So pen drives also came, right? Flash drives are coming. What are flash drives? What are flash drives? Do you know?
Yes, ma'am. Pen drives and all.
Flash drives are your
Bootable
SD
devices are
cards,
flash
like
drives.
you use in cameras or in mobiles. You use a SD card, na, for extra storage. Yes or no? In mobiles, your RAM
Yes,
and
ma'am.
ROM.
Yes, ma'am.
In mobiles, your ROM is also a flash drive. Do you know your
Why
data
the
is
flash
saved
drive name is given?
in your mobile? Your
For the
data is
third
saved where?
generation, and before the third decision, any hard disk type or any operating system is used or not?
What?
Before the third generation computer, any operating system or hard disk drive type system is used or not?
Where?
In the second generation computer.
In the second and first generation computers, no operating system was being used. It was punch cards, where you need to feed in binary format the data, and in binary format the output used to come. In third generation, your operating system started use, and your keyboard and the mouse and all that came into being. Right? So these improvements have kept on coming, and the language also. Your programming languages also have a different things developed. In the first generation computers, you used to use binary language. Do you know what is binary? Binary?
Ones and
Zero
twos.
and ones.
Yes, ma'am.
Yeah.
One and zero.
0 and
Yeah.
1.
Zero and
We will do calculation also, how to convert a decimal number into binary. There are 4 number systems which we talk about, that we'll talk about later, but I'm just telling you. So binary number system, computers have binary number system, right? Which have only 2 numbers. Bi means 2, right? Bi means
Yes.
2. So there are
Two.
only 2 numbers, 0 and 1.
One.
Right. So in zeros and ones only, it understand what is A. A also, if you type press A in your keyboard, what input goes into the computer is zeros and one only. A code goes for A. For B also a code goes. Right. So whatever you type in from the keyboard, the input which our computer takes is in the form of the binary digits. Right. So zero is generally, if you talk about electrical equipment, we talk about on and off, right? Always we
Yes.
say that any electrical equipment is either we do on or we do off, right? So same way in computers also, 0 is off, 1 is on, because it is a digital electronic computer, right? So the pulses, electric pulses which goes into the computer are 0 and 1 only. So it calculates everything in 0 and 1. Right. So the first generation computer, what language was used in the computers was binary language, which is known as low level language. Right? Low level language it was known as. Then in second generation, when you come to second generation, right, there were different languages which were developed. One of the language was assembly language, which was near to the binary language, but it had different mnemonics or codes which were written in English, that like add has ADD, subtract has SUB. So it had a little English language influence on it, so you could more easily understand that. So later on in second generation, assembly language was developed. It was still a low level language, not a medium level language. Then in second generation, at the end of second generation, more languages were developed, like like Logo, Basic. Different languages were there. They were medium level languages, right? COBOL. So they were medium level languages. Then in third generation, high level languages were developed, which is C, C++, Java. Right now, all the languages which are being developed are all
High level
languages, right? Python. So all these languages are right now getting more and more advanced, more and like .NET has been developed, where C has become C sharp, right? So say you can say C++ has more improvement, and now in .NET technology it is known as C sharp, right? You have J Sharp also. So there are different technologies where you are developing. Java is also more advanced now. So these are the things which are getting advanced. Earlier Python was not being used so much. Now Python is also coming into market. The new version, the 3 point something version is being used more. Right. So more advancement has been done in the different languages. So these are high level languages which are being used right now. So you have low level, medium level, high level.
High level.
So this has also came into being. So this is what history of computer was there. Then one more thing I need to tell you. So we talked about certain things, but a brief timeline history of computer I'm talking about. So it was before 1939. It was pre-electronic digital computer era. So whatever was developed, like you have seen the different machines which we had talked about, the Hermann Hollerith, the Pascaline and all that. So prehistoric era was electronic era was there. Then came first generation electronic digital computer, which is 1939 to 1954. Then first programming language was developed in 1950 to 1965. Then second generation transistors transistors came into being 1939 to 1954. It is said. Personal computers came into 1975 to 1990, which we are using. PCs we are using right now, basically. Right. Then present and beyond is your fifth generation generation, which we are going. So we had already talked about these machines. I'm just this is Charles Babbage. This is his machine,
Father of.
which we talked about, right? The difference engine. This is Hermann Hollerith machine. Now, in 1936, Alan Turing presents the notion of a universal machine, later called the Turing machine, capable of computing anything that is computable. So, in artificial intelligence, you also talk about Alan Turing, and he developed many machine kind of a thing, which is known as Turing machine, which could calculate anything which you give. So the central concept of the modern computer based on his ideas, Alan Turing, right? So he was also the person in 1936 whose ideas were later on taken into computers, right? Then in 1937, this is J.V. Attensoff, a professor of physics and mathematics at Iowa State University, and attempts to build the first computer with gears, cams, belts, or shafts. Basically, a mechanical computer which had gears, which had cams, which has belts, which has shafts. So he's also one of the persons who developed a mechanical computer, right? So this is his machine.
Ma'am, what is shafts?
What is?
Shafts.
Shafts is same like belts, na? What you can say, rubber kind of a belts are there, or you can say, what can we say about shafts? A strong strips like things are there that are known as shafts. To run the machine, the shaft rotates it, right? For rotating, you need ribbons, na? Right? So
Yes,
that
like
is
an
known as
engine.
shaft.
Yes, ma'am.
So that machine was developed by Attensoff. So this is the Attensoff Berry computer. This is a mechanical computer he developed. So this is how it was actually. So this is in 1943 and 1944, two University of Pennsylvania professors, Johnny McClure and J. Presser Eckert, built the electronic numerical integrator and calculator. This is ENIAC machine. This is in first generation, and considered the grandfather of digital computers. So they are known as the grandfather of digital computers. It filled a 6 meter by 12 meter room and had 18,000 vacuum tubes. See how much room it required and how many vacuum tubes it required, right? So how was the your height of the CPU, your length of the, and how much ton it was weight? So they are given that. That is not important, but I'm just telling you, a lot of heat was generated in these kinds of computers. Right. In 1946, the same Macleay and Presser, they also made another machine which is known as UNIVAC. Right. The Pennsylvania received funding from the Census Bureau to build the UNIVAC, the first commercial computer of business and government applications. So basically, this was the first commercial computer for use for business and government applications. So this was UNIVAC. Right. This is John von Neumann. Do anybody knows who is John von Neumann? No.
No,
John,
ma'am.
John von
No,
Neumann is
madam.
the
No,
yeah.
ma'am.
I'm telling you, John von Neumann is the person who is the architect of computer. Do you know what is the architecture of computer? You have input unit, you have output unit, you have CPU, you have memory unit, right?
Yes, madam.
Yes, ma'am.
So this
Yes, ma'am.
architecture was developed by him, John von Neumann. He is the architect of the computer. He said that all the computers should have an input unit, output unit, CPU, memory unit. So in 1946, John von Neumann discovered that the program statement could be recorded in binary form. So he was also the person who said that the computer could understand the binary language, and in binary form you could record the data inside the computer. Right. So he is the architect of the computer. Father of computer is Charles Babbage, but architect of computer is John von Neumann. Right. So this is the John von Neumann's architecture. He said you should have CPU, memory, input output. So these are the address bus, data bus, control bus, where all the information goes from these buses to memory to CPU, vice versa. Right. This is the architecture of John von Neumann architecture. So he is the architect of computer. In 1945, this was the computer they developed. Then the transistor. Who developed the transistor? In second generation, your transistor had come na. 1947, William Shockley and John Bardeen and Walter Brattain of Bell Laboratories invented the transistor. They developed the transistor, which made your ICs, which made now your miniature. Everything is made from this transistor only. So they discovered it, right? So it had an electronic switch, and you did not need any vacuum tubes and all for this, right? So in this is in 1953, Grace Hopper develops the first computer language, which eventually becomes known as COBOL, common business oriented language. Common business oriented language. The full form was this for COBOL. But this was not the first computer language. Actually, the first computer language was developed by lady. I don't remember her name. Ada. The first computer language was Ada, and it was developed by Lady Lovelace. Ada Lovelace. Her name was Lady Ada Lovelace, and on her name the language was developed. That was Ada. So that was also there. Then came Fortran. Do you know what Fortran is? Also a medium level language. Formula translator. The full form of this is formula translator. So this was used for calculations, mathematical calculations and all. So in 1954, Fortran programming language was born, right? This is Jack Kilby and Robert Noyes. They developed this IC. Who developed the IC or who is the inventor of IC? They both are in 1958. Jack Kilby and Robert Noyes, which we are right now using it in our systems and all, the ICs. Right, so Kilby was awarded the Nobel Prize in Physics in 2000 for his work. For this, he got the Nobel Prize also. Then in 1964, Douglas Engelbart shows a prototype of the modern computer with a mouse and a graphical user interface. So he developed the graphical user interface, or you can say the operating system. So this is Douglas Engelbart, and he's showing a prototype of a modern computer having mouse and keyboard and all that. Right. Then in 1965, Moore's law, the number of transistors in a dense integrated circuit doubles approximately every 2 years. So Moore's law tells you that your IC, how many transistors are put on the ICs, that is doubling your speed. So your speed is increasing, your chip is getting smaller, your speed is increasing more. So that is what Moore's law is all about, right? And they are the persons who develop Unix language, father of Unix operating system. Operating system. Yes, the Unix operating system was developed by Ken Thompson and Dennis Ritchie. Do you know who Dennis Ritchie is also the developer of C language? Dennis Ritchie is also the developer of C language, and Unix is fully made on C language, right? The code of the Unix operating system is fully based on C, right? Linux and Unix code is fully based on C language. So Dennis Ritchie is the person who developed the C. So these are both the persons who developed the Unix operating system. Ken Thompson and Dennis Ritchie. Then Alan Shugart in 1971, they are the team of IBM engineers who invented the floppy disk. They are the persons who invented floppy disk. Now nobody uses floppy disk, nobody has seen also. Now generation will not be able to see floppy disk, but this was a floppy disk. It has a problem that once it has dust or something gets inside the floppy disk, the data was corrupted and you could not get the data out of it, which is not the problem with CDs and DVDs. So this was floppy disk. Now in 1973, the Ethernet, or you can say internet kind of a thing, was developed, how a system can have network capabilities and all that. So that was developed as Ethernet thing. So Robert Metcalfe was the person who developed that in 1973. So you could transfer data from one computer to the other in a network. So that is what was developed. In 1974 to 1977, also different computers, Mark 8, Altair, IBM 5100, Radio Shacks, TRS-80. These were all the computers which were in the market at that time. India was not using it, but in foreign American countries, they were using these kinds of computers at that time. Then in 1975, Paul Allen and Bill Gates write their first program using BASIC language. BASIC was a medium level language. So on April 4, the two childhood friends formed their own software company. You know, now Bill Gates was the chairman of Microsoft.
Yes, ma'am.
Right?
Yes,
They
ma'am.
both,
Yes, ma'am.
Yes,
they,
madam.
yeah, they both have introduced the company Microsoft, right? And now Bill Gates is the chairman of that. So then, who is Steve Jobs? You know, Apple Computers.
Apple.
Yes, ma'am.
Apple.
Steve Jobs and Steve
Yes, ma'am.
Wozniak, they started the Apple Computers on April Fool's Day and roll out the Apple One, the first computer with a single circuit board in 1976. And now you know what Apple Computers are doing. Apple is doing, right? So this is one of the machines of Apple, Apple II at the West Coast Computer Fair. So these were the different machines they developed. Then IBM developed a personal computer introduced on August 12, used the MS-DOS operating system, Microsoft DOS, disk operating system, the first operating system. So this was IBM's international business machine, the IBM company. They developed this machine. So it had Intel chip, 2 floppy disk, and an optional color monitor. So this machine was developed at that time. The first Macintosh, that is Apple's computer in 1984. This was the first computer, Mac OS it had, right? This is Steve Jobs. You all know him, right? Then in 1985, Microsoft announces Windows. So Microsoft now started their own operating system known as Windows, right? So it was 3.1, then 1995, whatever. So that was in 1991, Linus Torvald, a Finnish student, creates Linux, a Unix-like operating system. So later on, Unix was developed and now it is known as Linux, which is an open source software, right? So that was developed by Linus Torvald. This is the logo. The penguin is the logo of Linux, right? And in 1990, do you know who is Tim Berners-Lee?
No, ma'am.
No, madam.
He's the person
Internet, ma'am,
who,
HTML.
yes, who introduced www to the or internet to the world. He is the person, right? www World Wide Web. He was the person who developed that, and he also developed the HTML language, which is the basic language for the World Wide Web, right? So he is Tim Berners-Lee. Internet started the internet, you can say. And these are the persons: Google, Sergey Brin and Larry Page. They are the developer of what? The Google search engine at the Stanford University, and now Google is a company, right? First
Yes,
it
ma'am.
was. So then in 2001, Apple unveils a Mac OS operating system. Microsoft rolls out Windows XP, which has, so basically now your operating systems are getting improved. In 2001, Apple was making Mac OS X operating system and Microsoft was doing XP. Then later on, another version of Macintosh was coming. Windows was 7, then 10. So it is kept on doing that. So 2004 Mozilla Firefox. Do you know Mozilla Firefox? What is
Yes,
that?
ma'am. It's
Yes,
an
it's
internet
a
browser.
search engine.
Web
Search
browser,
engine.
ma'am.
Right.
Web
So web
Yes,
browser.
ma'am.
browsers. So different web browsers were introduced, like Microsoft had Internet Explorer. So Mozilla Firefox has been introduced. So you have Safari. Now the many browsers are there. Google Chrome is there. So these are the. Then in 2004, Facebook, a social networking site, was also launched. Who is the owner of this?
Mark
Facebook.
Zuckerberg.
Mark Zuckerberg, right? Then in 2005, YouTube, a video sharing service, was founded. Google acquires Android Linux-based mobile phone operating system. So Google has whose mic is this? Muted. So YouTube was also founded in 2005, and Google also acquired Android. So now all the phones which you which are running Android operating system, are having Google only. Basically, it was developed by Google only. So 2006, Apple also introduces a MacBook Pro, its first Intel-based dual-core mobile computer, as well as Intel-based iMac. So this is your laptop, or you can say a dual core mobile computer. And then in 2007, iPhone was introduced in 2007 by Apple. Then iPad in 2010, right? And 2012, Facebook gains 1 billion users on October 4th. So basically, the more users were added in Google, and this is what now we are going into, right? 2014, Google releases the Android Wear. 2015, Apple releases the Apple Watch, right? So this is what we are going into, right? So what next? Maybe some things will appear more smaller than this later on, right?
Right, ma'am.
This is what the history is all about, right? Then we talk about our fundamental of computer. Uh, like we talked about first, that I asked you what is a computer. We had talked about that it's an electronic device used to process data. So computer can convert data into information that is useful to people. And what does a computer system includes? It includes the hardware, it includes the software, it includes data, it includes users. Yes or no?
Yes, ma'am.
Yes,
So
ma'am.
Yes, ma'am.
what is the
Yes,
difference
madam.
between a hardware and a software?
Hardware we can touch it. We can give command through hardware, and software is programs where we can do our work.
So
We cannot touch software.
hardware is all the things which are peripheral or you can touch them. Hardware are devices which you can touch, right?
Yes, ma'am.
Yes, ma'am.
Right. But software
Yes,
are
madam.
not the physical devices. right? It's a program or instructions which are given to the computer, right?
Yes, ma'am.
Yes,
And
ma'am.
what is data?
Information.
And data is the information that we
Information which
store
we
in the
provide.
computer.
Yeah, but if we talk about data, so data can be raw also. Raw data means right now the data is not in a completely processed form, not an information, but data, right? So it can be anything. And users are, who are users? We are the users, right? So these are the basic things which a computer has. So when we talk about your data or information is given to the computer through keyboard or whatever form it may be, and then your different hardware devices like your CPU processes it, right? And then your softwares are your operating system, your different applications, your MS Office may be there, your browser or whatever it may be there. So software programs will process it and it will give the output to the CPU, and again the CPU will show it on the monitor. The output is this. Basically, this is all the computer generally works. So users are also working, data is there, data is supplied by the user, hardware and software works together to give you the output, right? So what is hardware? Hardware consists of electronics devices, the parts you can see and touch. The term device refers to any piece of hardware used by the computer such as keyboard, monitor, modem, mouse, whatever. All are hardware devices, right? Then if you talk about hardware devices, if you see, these are the different hardware devices you have. Yes, you have speakers. These are the speakers, right?
Yes,
Modem.
ma'am.
Where is the modem? This is a modem. You have microphone. This is your microphone. You have RAM. RAM is inside your computer. These are the RAM, right? And your CPU is your chip. Microprocessor chip will be your CPU, right? Your keyboard, mouse, right? CD-ROM. CD-ROM is here, right? This is your CD-ROM. This is your diskette drive. That is floppy drive, right? Then your hard disk is there. This is your hard disk. Then printer is there. Printer is this one. Ports are there. What are ports? These are the different ports. Like
Ports
where
are
your,
used to communicate with the other devices.
yes, your ports are on the motherboard to connect the devices which are there. Like speaker, you need to connect to the audio port, and the printer you have to connect to the parallel port. You have USB ports also, right? Those are ports where you connect these devices. Those are known as ports. Then you have monitor and expansion board. Expansion board is if you want to add like sound card or graphic card, so you have expansion slots inside the motherboard, so you can add more chips to that, and you can have different additions also. So these are the different hardware we talked about, right? Then we are talking about software. So softwares are all called programs, consist of organized set of instructions for controlling the computer. Some programs exist for the computers used to help it manage its own tasks and devices. Other programs exist for the user and enable the computer to perform tasks for you, such as creating documents. So basically, computers, if you softwares, if you talk about, are all programs or instructions, set of instructions. A program, if we talk about, if we are saying software is a program, then what is a program? Definition of a program is set of instructions, right? Set of instructions means the instructions written in that program that the software will perform, right? So they are written in some programming languages, something the set of instructions must be there so that it follows, and that is what the computer does. Right. So they help you even if when you go on to other semesters or later on semesters, you will also write your programs in C or C++. So those programs will implement the instructions you have given in that program. So that is what software is basically. And data consists of raw facts which the computer can manipulate and process into information that is useful to people. Right? Computerized data is digital, meaning that it has been reduced to digits or numbers. The computer stores and reads all data as numbers, 0 and 1. Right? Computers understand only binary, right? So all the data which is inside the computer is in the form of 0 and 1, right? So although computers use data in digital form, they convert data into forms that people can understand. So basically conversion is also possible because what we will not be able to understand 0 and 1, right? So what it will do is it will convert the data into our readable form, like text, numbers, or sounds and images, whatever. So conversion is also there. Then users
how to describe the computer as a data processor?
It processes your data, na? You have given some data for processing, like calculations you are adding, you are subtracting. So it is processing your data and giving you the answer. That's why it is called data processing. No. Yes or no?
Yes, ma'am.
ma'am.
So that's why it is
I
called a
am.
data processing machine. So it is taking your data, even if you are putting it in Excel, you are putting it in some form now. Your name, enrollment number, one column you are putting. So it is giving, and then if it wants to calculate that how many people are there in the class, right? So you can do that also,
Yes, ma'am.
right? So that is what data processing is all about. So users are the persons who are using the computers, like we are the users. So the users can be specifically using it or sharing it or whatever they may be. So that is users are the persons, we are the persons who are using it. So computer architecture, you have hardware, you have CPU, you have memory. So these are the input-output devices, storage devices. So this is what the computer has, all the things. So first, the type of hardware. What are the different types of hardware we have in our computer? You have processor, yes, chip, right? Processor you have memory, you have input-output devices, you have storage devices. Yes or no?
Yes, ma'am.
Processor chip is
No, no.
also a hardware. Memory chip, RAM, ROM, or whether it is hard disk, whatever, they are also hardware. Input-output devices, that is your keyboard, mouse, printer, whatever it is, that are also hardware devices. And storage devices, that means your hard disk, pen drives, CDs, copies, whatever, those are also your what? Hardware devices.
Hardware.
Ma'am, can memory can be a storage device?
Memory cannot be storage device. There is a difference. What is the difference between memory and storage? Can anybody know?
Memory bullet drive.
Because you can store on memory,
And
no?
memory is used to store a data for a limited time and
Yes. Like if I give you an example of memory and storage, memory is temporary and storage is permanent. Right? Like for an exam, can you mute your mic, please? Your disturbance is there in your mic. Whose mic is this? Yeah. So when we talk about memory, suppose you are you want to give your exam is coming, so you study for the exam, right? And write your papers, and after that, do you remember everything after finishing your paper?
No,
No,
ma'am.
ma'am. Everything not.
No. So
Not
that
everything,
is
but
memory.
little.
That is memory, temporary, right? And some of the things are fed in your brain, which are in your mind always, or you never forget that. That is storage, right? You do everything on that basis only because it is fed in your mind from childhood or whatever. So it is in your mind, you never forget that. Do you understand?
Yes,
Yes,
ma'am.
ma'am.
Thank
Yes,
you.
That is
ma'am.
storage. So same way here also computer has two types, two things, memory and storage. Memory is RAM, read only, random access memory, right? Which is temporary, which forgets after the power goes off, right? But storage is permanent. It will not forget even if the power goes off. It will keep the data. So that is what the difference is, right? We'll talk about that later
Yes,
also.
ma'am.
So here, when we see here, see your processor is there, your memory is there, input output devices are there, storage is there, right? So this is your actual computer basically, right? So these are the different hardwares. When we talk about CPU, what is the full form of CPU?
Central
Central
processing
processing
unit.
Central
unit.
processing unit.
It's central processing unit. So central processing unit is your chip. Your microprocessor chip is your CPU. When we talk about this picture is also not showing that. This picture is showing you the cabinet, right?
Yes,
Right?
ma'am.
If somebody asks
Yes,
you,
ma'am.
what you say, this is the CPU, right? Generally, if somebody asks you where is the CPU, so you show the cabinet, you point at the cabinet and say this is the CPU. But that is not the CPU. That is a cabinet which has a motherboard inside, and on that board is a chip, microprocessor chip, which is the CPU. This whole box is not the CPU, right? So what is the work of the CPU is to process the information, right? Transform raw data into information. Processing is the work of the CPU. So all the things which are being calculated, processed, the data is processed is done by the CPU. And what are the parts of CPU? Do you know?
CU and
Ma'am,
ALU.
ALU and CU.
Yes, control unit and arithmetic logic unit. So all the, just hold on for a second. Yeah, sorry. So we were talking about CPU. So your parts of the CPU generally manages, your central processing unit generally manages all the devices and all the processing work which is going on, but it has two parts, control unit and arithmetic logic unit. So what is the work of control unit? To manage all the things which are coming to the computer, the devices information, and whatever input is coming, whatever output is going, everything is managed by the control unit. It is managing the whole things, right? And processing, that means calculating, is managed by ALU, arithmetic logic unit. Whether it is logically, whether arithmetically, so these calculations are done by the ALU, arithmetic logic unit, right? So CPU has two parts, control unit and arithmetic logic unit, and both of them combined work as CPU, and the CPU processes or manages all the devices and does the processing of data, right? So CPU consists of one or more chips attached to the computer's main board, main circuit board, or you can say the motherboard. So it is attached on the motherboard. Here, a board is there on in your system. On that, a chip is attached, your Intel or chip, that is your microprocessor or the CPU. Sorry. So when we talk about memory, so we already discussed that memory and storage are two different things. Memory is temporary and storage is permanent. So memory also consists of chips attached to the motherboard. So memory holds data and program instruction as the CPU works with them. So this memory is called random access memory or RAM. So basically, when you switch on your computer, you require memory for that or not? When you switch on the computer, the operating system will be on, right?
Yes, ma'am.
Yes,
So
ma'am.
it will
Yes, ma'am.
require memory to be somewhere where
Yes,
it
ma'am.
can get on. So that memory is your RAM, random access memory, right? And whatever processing you are
Yes,
doing,
ma'am.
Suppose you are adding some numbers or something, whatever you are doing, you are typing on the something on MS Word. So whatever you are doing, it requires memory or not. If you are typing, it must be in some memory. Where you the word typing, you can see that your letters are being typed and a sentence is being made, but it is somewhere in the memory, na? It must be somewhere in the memory, right? That memory is also RAM. You are calculating something, output is coming, that memory is also RAM. Do you understand that?
Yes, ma'am.
Yes,
Yes,
ma'am.
So
ma'am.
so compute CPU works with the memory, so to hold your hold the data and instructions which you are giving. But it is a temporary memory. That means when the power goes off, so your Windows was running, your Word was running, your whatever you had opened was running, but power goes off, it will not be at that level only when you switch on the computer. It will again start, right or wrong?
Right, ma'am.
It will not be at the same point where you have where the computer was switched off. It will again start the operating system. Then you will on the Word, but whatever you have typed on the Word will be gone, because you have not saved it permanently, you were just typing, right? So that is on RAM. So RAM in your computers or in your computer system, it forgets when the power goes off. It is temporary. But in your mobile phones, RAM is a RAM again there things are same way things are there in mobile also. RAM is the same thing, it is happening, but generally mobile phones only get switched off, otherwise, right, when you don't have what you say power, that much power, right, then only it happens. Otherwise in mobile phone generally you recharge it, so it doesn't matter. But in systems, if you don't have UPS, that is unlimited power supply, UPS facility is not there and power goes off, and then what happens in the system? Everything goes
Shuts
off.
down.
It shut down.
Yeah. So the CPU can find any piece of data in RAM when it needs it for processing. RAM is volatile. See, another word for temporary is volatile, right? Another word for temporary is volatile. That means it holds data only when the power is on. When the power is off, RAM's contents are lost. That's why RAM is called volatile. And ROM. One more memory is there, ROM, read only memory. ROM is non-volatile because the data inside ROM can only be read and it is permanently saved. Do you understand? So this word volatile and non-volatile, all of you should know. Volatile means, what does it mean?
Temporary.
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 Temporary
That means,
memory.
it holds data only when the power is on. When power goes off, it will lose the data. So that you should remember. Suppose your exam is in objective form, right? So this kind of a question may be asked. Which one is the volatile memory? So you will keep on seeing RAM, ROM, hard disk, many things are given. Then you should know that RAM is volatile only, right?
Yes, ma'am.
Right, ma'am.
Then how memory is measured? Now, how is memory measured? So first and foremost, you should know the smallest unit of memory. Do you know which is the smallest unit of memory in computers? We are not talking
Bytes.
about
Bits.
Nibble.
Bytes.
Nibble. Nibble. Nibble.
bit is the smallest unit of memory, right?
Yes.
Like we have gram, kilogram, whatever. Same way, there also smallest unit is there. Here also smallest unit is bit, 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 right? Now, this smallest unit can also be made a nibble, which is 4 bits, right? One nibble is equal to 4 bits. Then comes byte. So one byte is 8 bits. Generally, this question is asked in many entrance exam also and many objective papers also. One byte is equal to 8 bits, right?
Right, ma'am.
1 kilobyte is 1024 bytes. Now, how does this 1024 came? Right? To understand that, I'm just opening Word. Acha, I told you that binary computer can understand binary, right?
Yes,
Yes,
ma'am.
ma'am.
So binary has how many things?
0 then 1.
Zero and one.
Right? Two numbers only. That is why I'm just increasing the font. So two numbers only, 0 and 1. So everything is the base of binary is 2, right?
Yes, ma'am.
Two numbers only, na, 0 and 1. So base is 2. So everything which is calculated in binary is the power of 2, right? So if we talk about 2 to the power 0 is what? Can anybody tell? Anything to the power 0 is
Equals to 1.
1. Remember that. In any calculations, remember that anything which is to the power 0, whether it is 8 to the power 0, 2 to the power 0, 4 to the power 0, anything to the power 0 is 1, not 0. Then when we talk about 2 to the power 1 will be equal to 2. What does power mean? Everybody knows that or not?
Yes, ma'am.
Calculating the power, everybody knows.
Yes, ma'am.
2 to the power 2 means 2 into 2.
4.
4. 2 to the power 3 means 2 into 2 into 2. 8 times. Right? So what is that?
8. Ma'am,
8.
someone's
So
mic
we
is disturbing.
whose mic is this? So we keep on calculating. 2 to the power 4 is 16, 5 is 32, 6 is 64, 7 is 128, 8 is 264, 9 is 5112, and 2 to the power 10. I am straight away going to that. You should remember this thing. Always remember that. 2 to the power 10 is 1024. 2 multiplied 10 times is 1024. Remember that. Do you understand?
Yes, ma'am.
Yes, ma'am.
That's why
Yes, ma'am.
when we are talking here,
Mr. Rahul, can you mute your mic? It's continuously disturbing.
so 1 kilobyte is, that's why equal to 2 to the power 10. That means 1024 bytes, right? Not bits. Not bits. What is it? 1024 bytes. If I want to convert this into bits, what will I do?
Multiply by 8.
Yes, 1024 multiplied by 8 will be in bits. But that we are not doing it. I'm just telling you. Right. Then when 1 megabyte, when we talk about MB, that is 1024, what is it? KB, not byte. What is kilobyte? Right? So 1024 KB means 1024 into 1024. 1024 this, and kilobyte is also 1024. In bytes I am talking about. Do you understand what I am talking?
Yes, ma'am.
So 1024 KB will be 1024 into KB ka 1024 or 2 to the power 20 bytes. This is 2 to the power 10, this is 2 to the power 10. So how much it will be? 2 to the power 20 bytes in bytes. Right? Same way when we talk about 1 gigabyte, 1024 MB, megabit. So it is 1024 of this, and megabit is 1024 into 1024, so 3 times 1024 in bytes, right? That means 2 to the power 30 bytes, right? And when we talk about the next one is 1 terabyte. 1 terabyte is 1024 GB. That means 1024 this, and GB has 1024 into 1024 into 1024. That means 4 times 1024 bytes. So that means 2 to the power 40. And when now again one more thing has come, 1 petabyte. Do anybody know about petabyte?
Yes, ma'am.
Petabyte is 1024 TB, right? Petabyte, if we talk about, it is 1 petabyte, that is TB, it is known as, and 1 petabyte is equal to 1024 TB. So how much it will be? 2 to the power how much?
50.
40.
50. 50 bytes. 4 times, now 5 times you have to do. Right?
Yes,
So
ma'am.
that has also come. So this thing you should all know. How is memory measured? So your hard disk is becoming more and more now. Right? Now if you buy a laptop, you are buying in terabytes your. Later on it will be petabyte. But Zeta, Zota has also come. Do you know that?
Yes, ma'am.
Zeta and Zota, these all have also come. I think something like that. Zeta and Yota
Hepta
hai,
and
Zeta hai.
ma'am, I think Hepta and Octa are also there.
That's what I'm saying. These have also come because now the data is too much. If we talk about Facebook, YouTube, and all the Google and all that, they have Zeta, Zota, and all those bytes data. That is known as big data. Yes or no?
Yes,
So
ma'am.
much data is there. So that has also come in the market. So find out, your job is to find out how much is Zeta, Zota, all those bytes are how much. Right? You should know all. I'm not saying ki this is what your study is saying. From the point of view of your study, it is up to terabyte. But from the point of view of latest things, you should also know that. That's why I'm telling you. Right? So this is what we talked about. This is not important. Then we are talking about input-output devices. So input devices are what? What are input devices? Which accept data and instructions from the user or from another computer system. Like keyboard, mouse, they accept data from the user and give it to the computer, inside the computer. And output devices are what? Which return the process data back to the user. Right? So your printer, monitors are your output device. Your monitor shows you the input also and shows you the output also. Yes or no?
Yes, ma'am.
Yes, madam.
Right. Then you have communication devices also. Like modem. Modem is modulator, demodulator. That is, it converts analog information into digital and digital information into analog. Right? Where in a modem a telephone line is attached. Yes or no?
Yes, ma'am.
Yes.
So on a telephone line, what kind of data goes in the telephone line?
Analog.
Analog data. That means you are speaking now, your voice goes into the telephone line. Yes or no?
Yes, ma'am.
So that is analog. Voice is analog form. But that I don't need in my computer an analog information. I need information in digital format. Yes, in one or zeros, which the computer can show. Like on the internet, you connect to the modem and then you access the data from the internet. Yes.
Yes, ma'am.
So that
Yes,
conversion
ma'am.
is done by the modem. It converts data from analog to digital and digital to analog, vice versa. That is modulator, demodulator. That you have network interface card, NIC, which connects your modem with the LAN or the network card inside your computer. That is NIC, network interface card, right? Where your Cat5 cable or something is attached to the laptop. Nowadays, people are using Wi-Fi modems or routers, but earlier when cable modems were there, so you needed network interface card in your system to connect to the internet or connect to other devices. So these are also communication devices. So these are the input-output devices you have, but there are other examples also. So then you have storage devices, right? Storage devices apart from your RAM and ROM, that is memory devices. You have storage devices like hard disk, right, which keep your data permanently, right? Hard disk is also known as magnetic or magnetic disk. Hard disk is also known as magnetic disk. You also have optical disk also, like CD, DVDs. Optics. Why optics is used? Do you know? We are saying magnetic or optical disk. Magnetic. Why magnetic? Because the technology being used inside a disk is through magnetic thing. They are storing the information. Information is stored on magnetic disk, right? And optical disks are which are read through lights, like CDs and DVDs use laser light to read and write the information in CDs and DVDs. So optical devices are also there. Optical discs. So they are permanent storage or storage devices. So they use different medium to store or to read or write the data on its surface. So disk drive is a device that reads data from and writes data to a disk. So disk drive, like your floppy disk drive or CD disk drive. So these are these drives help you to write data onto the disk or onto the CDs or DVDs or whatever is there. So those are required in your system for storing information on those disks and reading the information. So the most common optical storage devices are CD-ROM and DVD-ROM. Right. So these are the things. So they are just telling you these floppy disk drive is there, CD-ROM drive is there, hard disk drive is there. Right. So these are the storage devices. Then we have already talked about software, which is a set of electronic instructions that tells a computer how to do certain tasks. A set of instructions is often called a program. So whenever you tell that what is a program is a set of instructions. So when a computer is using a particular program, it is said to be running or executing the program. The two most common types of programs are system software and application software. Right. System software is your operating system, and application software are all those which are installed on your operating system. Like MS Office, you install some other softwares like browser you install, or you install some programming language on the operating system. All those are application softwares. Same way in your mobile, you have Android mobile, that is your operating system, that is your system software. And on that, you install WhatsApp, you install whatever Office or whatever. Those are application software, same way. So basically, what the software does is the data is given and the to the application software, and the application software processes it, and the output is given in some form to the application software. So that is there. So system software exists primarily for the computer itself to help the computer perform specific functions. So basically, without the system software, the computer cannot work. So operating system is the most important system software, right? If you don't have an operating system inside your computer, would it work? Can you work?
No, ma'am. No, ma'am.
No, ma'am.
So that is the most important. That is the system software is the primarily for the computer. So computer, all the things are handled by the operating system. The computer fully, the hardware and input output devices, everything is handled by the operating system. So whatever, suppose in your printer a paper is jammed, the error message is displayed by the operating system that this is what has happened. So always remember, one major type of system software is the operating system. All computers require an operating system. The OS tells the computer how to interact with the user and its own devices. The common operating system include Windows, the Macintosh OS, OS/2, and Unix. So these are some of the examples we have given. And application software tells the computer how to accomplish tasks the user requires, such as creating a document or editing a graphic image. So certain tasks you want to do, like you want to edit a document, you want to edit a image, or you want to create a video or edit a video, whatever. So those require special application software. So those are known as application software, which are installed above the operating system, like word processing, database, graphics, web design, communication, entertainment, education. spreadsheet, presentation, networking. There are many utilities. Utility softwares are also there, like antivirus is a utility software which is helping you remove the viruses from the system. So there are different things which are there. Right. Then we come to classification of computer. So how computer is classified? Do you understand what is classification? So computer can be classified on the basis of technology. That means computers can be analog and digital. They can be classified on the basis of size and memory. On size and memory, you have mini, micro, mainframe, and supercomputers according to size and memory. And according to purpose, you have general purpose and special purpose computers. So this way computer is classified. So first, when we talk about analog and digital, so digital system use discrete signals as on or off, representing binary format. Off is 0, on is 1. Right. So that is digital. Analog uses continuous signal with varying magnitude. So voice can be that thing, temperature can be that thing, speed can be that thing. So analog uses continuous signals. Digital uses square waves, analog uses sine waves. Can anybody understand this? Square waves and sine waves? Class?
No, ma'am.
No. So if I want to make I'm just trying to, I don't know I will be able to. I'm trying, sorry. Taking shapes. So if we want to make an analog form of a thing, so suppose axis we have to make like this, one line. So suppose y-axis and x-axis we have made, and on that, if this kind of a thing is there, curve, this is known as waveform. You understand?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So this is the waveform. But when we talk about, binary or digital format, so this is not the thing. In binary format, square shape is used. So how square shape is used is, suppose I am doing this. Again, if I keep on making, suppose here what there is no this square or rectangle kind of a thing is not there na here. So this is 0. Where there this square kind of a thing is, this is 1. Do you understand?
Yes, ma'am.
Yes, ma'am.
So this kind of a form, if I just make it a group.
Ma'am, can you please explain one more time?
I'm just doing that. So if I want to denote this in binary, in digital means, so here I'll just write it in a text box. Here, what is this?
0.
This is 0. This is 0. And what is here?
1.
This is 1. Again here it will be
0.
0. Here it is 0. And what is here?
1.
1 more.
1
1 1. Two squares are there, na?
Yes, ma'am.
So
So
1
if
1.
there is nothing, it will represent as 0.
No, it doesn't depend, na. Your data can be 0 1 0 1 1 also, na. It doesn't matter. Wherever square is not there, it is 0. Wherever square is there, it is 1. Do you understand?
Okay. Yes, ma'am.
Just hold on. Yeah. So we were talking about, sorry. Yeah. So wherever, see, I have already told you 0 is off, 1 is on, right? Off means there is no signal right now. So base is, nothing is there, so 0. When signal is there, so the square box is 1. No signal, 0, square box, signal is there, 1 1. Do you understand?
Yes, ma'am.
So this
Yes,
is
ma'am.
what they are telling. The digital system uses square waves and analog system uses sine waves. Right? Then
Yes, ma'am.
digital system first transform analog waves to limited set of numbers and then record them as digital square waves. Basically, what digital systems do is, right now you have what you say, what is that? Blood pressure machines. Have you seen na? At home, some people are using blood pressure machines, digital ones. So what you do is you put the blood pressure strap on your shoulder, and then you on the machine, and it automatically the signal, analog signal is taken by pressing your shoulder, and the signal is converted to digital form and given the recording that this much diastolic or systolic is there, right? That is what digital system is doing. But analog system, what analog system used to do is physical waveforms were generated. That means earlier machines, what happened was you put the blood pressure strap on your shoulder, and the doctor used to press for compression. He used to press a thing, right? Remember that old one?
Yes, ma'am.
And when the blood the scale used to keep on increasing, and when he leaves the that ball, so it gives you the exact blood pressure. So that was your analog physically. So digital transmission is easy and can be made noise proof with no loss at all. That means digital transmission is easy because, and it can be noise proof. That is, no attenuation or no noise will be there in the, and no loss of data will be there. But in analog, systems are affected badly by noise during transmission. So basically, earlier telephone lines and all had a disturbance also. So noise problems was also there. Noise during transmission of data. So that is analog. Now there is no such problem. You have different digital formats come into being. Digital system hardware can be easily modulated as per the requirements. So flexibility is there. You can change the digital hardware and make according to your own requirements. But analog system hardwares are not flexible. So how they are made, you can use that way only. Right, digital transmission needs more bandwidth to carry some same information. Basically, digital transmission, suppose data is more, so you require bandwidth. What is bandwidth? Internet, the data which can travel from one place to another. How much data can travel? That is known as bandwidth on the wire. Do you understand?
Yes, ma'am.
Like you say
Yes,
100
ma'am.
megabits per second or 20 megabits per second, 50 megabits per second. That much is your bits which can travel from one place to another on the network. So that is that you need more bandwidth so that suppose 100 Mbps speed has come, 200 Mbps speed has come. So that means this much data you can transfer from one place to another. So more bandwidth is required. Analog transmission requires less bandwidth because it used to do limited things. So telephone had voice, so it can only transfer voice or speed or some calculations which it had to do. So it requires less bandwidth. Digital data is stored in form of bits, right? Smallest unit of binary is bit, so in bit form it is stored. Analog data is stored in form of wave signals, right? Like temperature, speed, everything is in wave signals. Digital system need low power as compared to its analog counterpart. Analog system consume more power than digital system. Right, so digital system nowadays low power consumption things have come into being, right? Compared to analog systems are there which consume more power. Digital systems are good for computing and digital electronics. Analog systems are good for audio or video recordings. If you want to do audio or video recording, analog systems are much better. Digital systems are costly. Analog systems are cheaper. Digital systems are computers, CD or DVD. Analog systems are analog electronics, voice, and radio using AM frequency. So these are your analogs. So
Ma'am, what is AM frequency?
Amplitude modulation it is. Frequency modulation right now is going on a FM in radio. Earlier it was amplitude modulation. In physics, if you had studied physics, you will understand what is FM and AM. But earlier, analog system, AM modulation was used for radio. Now frequency modulation is being used, right? So this is the difference of analog and digital. What's the time?
6:50, ma'am.
6:50.
6:50. So what I do is tomorrow we will go to our other part of the slide, which is size and memory, and we'll see how our computers uh, are differentiated. And then we will also learn about tomorrow binary number system. So all those people who are present right now, don't be absent tomorrow. Conversion from decimal to binary, from binary to hexadecimal, all the number systems we will study tomorrow, right? This is only theory part in the previous. Tomorrow we will also do practical things, right?
Yes, ma'am.
Okay, ma'am. Okay,
Yes,
ma'am.
ma'am.
So we will
Thank you,
do
ma'am.
that.
Ma'am,
Yeah,
I want to ask one question. Can I?
yeah, please.
Ma'am, I'm not having FEG 02 course on my LMS. What I can
Which
do?
course?
FEG 02
What you can do is,
Foundation in English.
have you attended that induction?
Yes, yes. I
Uh,
sent mail to IPO support.
Yeah, please give a
IGNOU.
mail to
But
them because that is not handled by me. That is handled by IGNOU headquarters only. So they are handling everything for the online courses. Just write to them that this is your enrollment number and this is your username, and you are not able to get the FEG2 study material on your system.
that has
LMS.
been done, ma'am, but no response has come yet.
I will convey it to them through. I have a WhatsApp communication with them, so I'll convey it to them that some students are saying that FEG2 has not been uploaded. I'll tell them.
Ma'am, I am also facing this issue, ma'am. I was
Yeah, I'll
sending
tell
mail to
them.
the
I'll
I'm
tell
also
them.
having the same issue with BCS-011.
BCS,
Same, this course.
BCS
Zero one.
011. You have not got
Yeah,
in your system.
not yet. All
Okay,
other courses
what
are
I'll
there
do
only
is
this one.
until I'll convey your message to them that some of the courses, either BCS 11, FEG 2, whatever, are not inside your system. But meanwhile what you can do is you go to IGNOU, or you can go to just say BCS 11. I'm just showing you BCS 11 study material PDF. Okay?
Yes, we
Right?
have download. I have
You
downloaded
can
all the
download
PDF.
from there also, the
Yeah,
same thing will be there, no problem. Same
but I am
FEG
not able to submit assignment and all. It have to
assignment
be
you
done
want.
through CMS, no?
Okay. I'll ask them that you are not also not getting the assignment, right?
Yeah.
Yes,
And
ma'am.
I have sent several emails. Only RC Dell even replied and it only forwarded to another email, but till now no response. I have
Uh,
sent reminders and
I
all.
am just those who have received, those who have got FEG2 assignment. Any person is there in the class right now who has got FEG2 assignment? Any person is there?
FEG, yes, ma'am.
Yeah, we
You
do
have got
have.
no? Just wait. I'm just you go to the IGNOU website, right? You have student support menu. Under student support, go to student zone, and under student zone you have different menus and you have assignments also, right? Go to that.
Yeah, actually, madam, they have sent another file with the download link for assignment earlier. But the problem is we cannot submit it. Submission is through LMS, no? If the course is added, then only we can submit.
Yeah,
That is the
that's what
problem.
I'm saying. I'll convey your problem with him. But right
Okay,
now,
thank
if you want FEG2, I think this one is there. This is the same assignment which you have got the link. I'm just asking you. This is the one.
And the second thing, I guess 2 or
This is the
3 days
one.
back, they extended the date again for 15th May. Is it valid for
Yes,
both
yes, ma'am.
online courses
They
as
will
well?
This is the one.
increase.
Yes, ma'am.
Yeah.
Ma'am,
So
but
you
it is
can.
not updated in LMS.
I understand.
It's still showing
Just
30th
meanwhile,
April.
until and unless it's not updated, just go to this assignments. All those who have not downloaded the FEG2 have not got the FEG2 assignment, just go to this BDP/BA1, click on that, click on FEG2, download the assignment, do it handwritten and scan it and keep it at PDF. When your that is allotted to you or that on the LMS portal, I'll convey the message to them. When it is allotted to you, you can attach it, right? Meanwhile, just do it. Do the assignment and keep it with you. That's what I'm telling
Excuse
you.
me, ma'am. Ma'am,
Yeah.
actually, for me, I can able to see those assignments, but on that assignment submission button is missing. It is
See,
available.
they will on it right now. Maybe they have not put it on. They will on it. I will convey your problems which are there. I will convey it to them that these are the problems they are facing on the LMS portal, and I'll tell them.
Okay, because I'm keep on sending emails since last week. I haven't got any response from any of those people.
Okay, and all of you have written your name and enrollment number on the chat box for attendance.
Yes, yes.
Yes,
No,
Yes,
ma'am.
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 Yes,
No,
ma'am.
no.
Just put
Yes,
it.
ma'am.
No, ma'am.
No,
We
ma'am.
need
I have not written now.
Just write it in the chat box, please.
Write your name and enrollment number.
Name
That
and
too is
enrollment
enough.
number, that's all. And please remember that please don't log in with any other, let us viral, who is this? Don't log in with any other name, log in with your name so that we are able to get the name of the person who is logged in, not some other names. If it is not on the, because
Yes,
I've got
ma'am.
the list of students now. I have to match also the list of students. These are the students with enrollment number.
Hello. Yeah,
Yes.
ma'am. Is there is any query? I have a query regarding what is the format of the submission of the assignment?
What is the
Format of submission of assignment.
format? See, handwritten assignments, theory assignment should be handwritten,
Okay.
right? Write it
Okay.
on A4 size paper or ruled paper, whatever it may be. Write on your answers on that
Okay.
and scan it and convert it into PDF or scan
Okay.
as PDF.
Okay.
One paper, one PDF.
One paper is one PDF. Okay.
Yeah, right. Theory. For the practical, that is BCSL 13. L will always be lab, that is practical.
Okay.
BCSL.
Okay.
L will always be your lab. So practical, right? Like you have to give an Excel output, or you have to make a presentation, or you have to
Hmm.
make a document. So that
Hmm.
can be given as a PDF of your output.
Okay.
That can be a printout or screenshot of your output.
Okay, and ma'am, second question is that in assignment there is a need to write the question.
No need to write the question. See, first, has RC1 forwarded you the initial form for writing? What should be the form for writing the assignment? Your
Okay.
enrollment number, name. Has they forwarded you?
No, I guess this is just the first page they have forwarded, not the
That's what
format.
I'm asking. Has they forwarded, right?
Okay,
They
first page we
forwarded the
have received.
first page where your name, enrollment number, course code, this that has to be filled.
Yes.
Right? Then your second page should be your IGNU ID. Third page should be your question paper of that assignment. Don't download your BCS-11, 13 and BCS-12. Three assignments are in one PDF. But when you are answering the question, you are making one PDF for one course code. So take out that those questions only. Take the question paper and attach it in your third page. Should be your question paper of that assignment, and then your assignment answers should be there. You don't
Okay,
need to
then
write the questions.
there are these videos. They are like ticking which one they are going to attend the question. They are ticking on the question papers.
Who?
There are some videos available on YouTube as well.
Who are ticking?
Like for submitting assignment, when you attach the
No,
third
you
page.
don't need to tick anything because assignments there is no option for you to write that this question has to be answered and this has not to be answered. There is
Yeah,
no
yeah.
such
So we have
option.
to attend all of those.
Yeah, all of them.
Ma'am, just one question.
In your question paper, that is your theory question papers, uh, that is offline mode. There you have option that first question is compulsory, and from the 4 questions you have to attend 3. That is during the question exam, not in assignments. Assignment doesn't have such option that you have to answer one and answer this. There is no option. You have to answer all. 80
Ma'am.
marks. 80 marks assignment will be there. 20 marks are for the Viva, and we'll see Viva how it has to be conducted, or we will give you marks according to 20. So that is there. I think that is what the thing. Yes, who is else?
Ma'am, is it okay we write the question also on assignment?
If we what?
Is it okay we write the question on assignment?
But you write the question and then write the assignment.
Yes, yes.
That is your wish, but you have to attach the question paper. That is your wish, but it is not necessary to write the questions. You just have to attach the question paper.
Okay.
Anything else? Has everybody written their name and enrollment number for attendance?
Ma'am? Yes, ma'am.
Yes. Okay. Yes, who is
Hello.
asking?
Excuse me, ma'am.
Yes, Prashant.
Ma'am, could you tell me about the last date of submitting assignment, ma'am?
Right now they have extended the date to May 15th. 15th of May.
Maybe May, ma'am, madam.
What?
May. Yes, ma'am.
They have
Is it
extended
extended
the
for
date
all the courses,
to
ma'am, or only BCS-11?
15th of May. Who else?
Ma'am, is there any official announcement regarding the extension of date?
Yes, it
I
is
didn't get
officially
anything.
announced there.
There,
It is
it must be on the website also.
Yes.
It must be on the website also.
हेलो हेलो यस मैं पूछना चाह रहा था कि जो एलएमएस है एलएमएस पे लॉगिन करने का प्रोसीजर क्या है मैंने बहुत बार ट्राई किया बट मैं लॉगिन नहीं कर पा रहा हूँ
आपको क्या ईमेल आया था आपके लॉगिन का इंफॉर्मेशन का?
नो मैम कुछ नहीं आया था ऐसा लॉगिन के रिलेटेड एलएमएस पे
देखो प्रोसीजर तो ये है, आपका एक लिंक है बीसीए ऑनलाइन जहाँ आपने एडमिशन के लिए अप्लाई किया था ना ऑनलाइन के लिए,
यस मैम
वहीं पे लॉगिन का भी लिंक होगा।
मैम बट वहाँ पे मैं चेक कर रहा हूँ मैम, मतलब 2-3 जगह चेक किया मैंने, कॉल करके भी पूछा बट हम पता नहीं चल पाया। इवन मैंने व्हाट्सएप भी किया बट समझ में नहीं आ रहा कैसे करना है वो।
Ma'am, can I take
Can I what?
लाइक ना अगर आप लॉगिन का लिंक में जाएंगे, लिंक को एक्सेस करने के बाद ना
आप यहाँ पे देखोगे, आप ये इस वेबसाइट पे जाते हो ना, ये BCA, एक मिनट कौन बोल रहा है? सुन लो पहले। माइक इज म्यूटेड। ये BCAOL करके आपका ये आता है। यहाँ पे लॉगिन किया था ना आपने?
हेलो, यस मैम दिख रहा है, यस
हाँ,
मैम
तो
दिख रहा
यहाँ
है।
पे नीचे देखो, यहाँ पे जब आप नीचे जाते हो, यहाँ पे लर्निंग मैनेजमेंट सिस्टम आ रहा है ना,
यस मैम।
तो यहाँ पे क्लिक करोगे। अरे ये गाना गा रहे हैं।
महराज भाई बंद कर दो।
तो यहाँ पे आपको अपना लॉगिन बनाना, क्रिएट करना है।
मैम वही तो मैम, मैं बहुत बार ट्राई कर रजिस्टर करने का ऑप्शन ही नहीं है।
फॉरगेट पासवर्ड तो है, फॉरगेट किया?
फॉरगेट करके भी देख लिया, इवन ईमेल आईडी और
लॉगिन लिखा हुआ है, लॉगिन
मैम
करो।
करके देख चुका हूँ वहाँ पे मैम,
आपका
लॉगिन भी किया
यूजर नेम, आपका ईमेल आईडी होगा
मैम,
जो
ईमेल आईडी
आपने
भी डाल के चेक किया मैम, ईमेल आईडी भी डाल के चेक किया, पासवर्ड भी डाल के चेक किया
सुन लो,
और साथ ही
यूजर
साथ
जो आपने रजिस्टर किया था जिस ईमेल से, कि कोई और ईमेल से करोगे तो नहीं होगा। जिससे आपने ऑनलाइन रजिस्ट्रेशन किया था, जब आपने फॉर्म भरा था ऑनलाइन में, वही यूजर नेम डालना है ईमेल।
मैम वही ईमेल डाला था मैम।
Listen, Amardeep, you can try it in uppercase. Okay, there's this problem that we saw in induction meeting. They have typed it in capital. So just type your email in capital and try to see if you get logged in.
Okay.
And if you are not able to, just say forgot your username or password here.
Okay.
And there was a initial somebody was saying there was a password which is a default password which they have created.
We have the default password was Jan 2020 something.
So
please ask it in the group.
J is capital.
Yeah, I guess J is capital, AN 2021 2022 I guess.
Who are not able to log in, please. Jan 2022. This is the password.
Yeah, I guess. No, it's please check the chat, Amardeep.
Default password if they are you are not able to.
మాట్లాడుకుంటా ఉంటే మనం
Ma'am, can you mute this one, please?
Anything else, or we'll connect tomorrow then? So today you have only one class. That is only for today. From tomorrow you will have two classes.
I'm still I'm unable to unlog. I'm unable to log in. Still, I'm not able to log in.
Amardeep, have you joined the group, WhatsApp group?
No. Can you please send me the link, WhatsApp link for WhatsApp?
Can you leave your email in the chat?
Yeah, thank you.
So everybody is done with their username and password. Meraz, please mute your mic.
महराज अपना माइक म्यूट कर लो।
मैं ही माइक म्यूट करती हूँ।
महराज प्लीज म्यूट।
I have muted him. So what I am telling you, we'll connect tomorrow, right? And tomorrow you will have two class, that is FEG2 also, English class, that is from 7 to 9 p.m. right? From now on you will always have two classes.
Excuse me, ma'am.
Yeah.
Where can we get the meeting link? Like I did not receive any email about this class.
See, you attended the induction?
Yes, I have attended
On
my
the
induction.
induction meeting, the email you have got, there was an attachment of counseling schedule also. And in that
Okay.
counseling schedule, you have meeting link also.
Okay, so the meeting link will be the same, right?
It will be the same which is there today
Okay. Thank
for
you.
all the classes.
Okay. Thank you, ma'am.
Hello, ma'am.
Hanji.
Ma'am, is there any process like our attendance recorded? We can check out
Your
like
attendance?
our attendance. Today's attendance is recorded. Is there any, like everything is online mode? So sometimes there is that will happen like on the learning management system. Uh, मतलब ऐसा भी होता है ना बहुत बार कि बहुत सारे पोर्टल्स में आता है कि आपने अटेंड किया है ये वाला सेशन कुछ टिक हो जाता है ऐसा भी होता है बहुत बार तो वो ऐसा कुछ है क्या
देखो लर्निंग मैनेजमेंट सिस्टम पे भी ऑप्शन है आपको अटेंडेंस डालने का अभी उन्होंने ऑन किया है कि नहीं मुझे पता नहीं बट एज अ फैकल्टी मुझे अगर अटेंडेंस लेना है सबका who all are attending I have to keep the data ठीक है
अच्छा आप बोल रहे थे कि ऑनलाइन मोड में एग्जाम होगा लाइक
वो एग्जाम से आप क्यों इतनी चिंता कर रहे हो देखो अगर वो ऑफलाइन भी हुआ सुनो उस दिन भी यही बहुत सारे क्वेश्चन पूछ रहे थे अगर एग्जाम ऑफलाइन भी हुआ इट डज नॉट मैटर क्योंकि जहां तुम हो वहां पे एग्जाम सेंटर अवेलेबल है इग्नू के कहीं भी हो तुम ऑल ओवर इंडिया तुम्हें दिल्ली आने की जरूरत नहीं है या कहीं जाने की जरूरत नहीं है जहाँ पे तुम हो वहीं बैठ के वहां का एग्जाम सेंटर सेलेक्ट करो वहीं बैठ के एग्जाम दो समझ में आया इवन इफ इट इज ऑफलाइन यू शो डोंट वरी अगर सपोज करो ऑनलाइन एग्जाम होता है तुम्हारा और वो तुम्हारा कोई सेंटर सेलेक्ट करने को बोलते हैं तब भी तो तुम्हें जाना पड़ेगा कि नहीं बताओ कोई कंप्यूटर सेंटर सेलेक्ट करने को बोलेंगे कि वहां जाके एग्जाम दो सपोज वो कोई ये तुम्हारे लैपटॉप पे ना चला पाए तुम्हारा एग्जाम तो जाओगे कि नहीं जाओगे बताओ बस ये इसमें क्यों इतनी चिंता कर रहे हो कि ऑनलाइन होगा ऑफलाइन होगा तुम बस पढ़ाई करो whenever the information comes तुम्हें ईमेल पे आ जाएगा whether क्या कब एग्जाम होगा क्या होगा ठीक है तो उसकी चिंता मत करो ठीक है तो अभी तुम बस पढ़ाई पे ध्यान दो अगर वो ऑफलाइन होता है तो भी तुम्हें चिंता करने की जरूरत नहीं है यू डोंट हैव टू कम एनीवेयर जो भी तुम्हारा स्टेट है वहाँ पे बहुत सारे इग्नू के स्टडी सेंटर्स हैं जो कि एग्जाम सेंटर्स भी होते हैं वहाँ पे जाके एग्जाम दे सकते हो सेलेक्ट करके देयर इज नो वरी
थैंक यू
ठीक है
Hi ma'am,
या
I am working abroad in Kuwait. Okay, what about
See that you have to talk to the IGNU center if there is in Kuwait there is an IGNU center just see that I think there are some study centers or IGNU centers in outside India also but you have to find out if Kuwait has a IGNU center there otherwise so you have to request IGNU that you are not able to give exam that is a possibility.
Yeah, sure. Thank you.
Welcome. So can we end the class today? We'll meet tomorrow again 5 p.m.
Yes, ma'am.
Yeah.
Okay.
So we'll meet tomorrow and everybody has put their attendance or not in the chat box.
Yep.
Yeah.
Yes, ma'am.
I'm copying.
Hello.
So now all of you can leave. We'll meet tomorrow and we'll discuss other things.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you, ma'am.